Right, what is the general term in the binomial theorem and how useful it is? To begin with, we're going to write down the binomial theorem. Right, so we're going to do a simple expansion. We're going to expand this. Okay, so I will substitute my a for the letter x. N equals to 3. Right, if we do a comparison, n is equals to 3. Right, substitute a to be the letter x and b to be the letter y. Right, so we have x to the power of 3 plus 3, 1. X to the power of 3 minus 1 is 2. B, you're going to substitute for the values of y. So 3, 2, x, 3 minus 2, it's 1. And B, it's y to the power of 2. And the last term, it's y to the power of 3. So we're going to simplify, you get x cubed. 3, 1 is 3c1. If you use a calculator, it gives you 3. Alright, if you've forgotten how to do that, just press 3 on the keypad, followed by Shift key, followed by the symbol NCR on your calculator, followed by 2. You should get 3 also. Let's verify. Yes, we should get 3. X, y squared, then y cubed. Alright, so let's look at this. So if you look at the first term, right, this is your first term. This one is your second term. This is your third term. This is your fourth term. So altogether, there are 4 terms when n is equals to 3. Alright, so in terms of, okay, so this guy here, wait, hang on. So this one is actually your general term. Okay, I forgot to mention, this is your general term. Okay, right. So in terms of this, this letter R here, this letter R, okay, if you look at the first term, this is when your R is equals to 0. Okay, if you look at the second term, you go up here. Second term, look here. This is the value for your R, right? That is the value for R. So if you look at the second term, this is when R is equals to 1. Then you come to the third term, this guy here, this is your R for your third term. R is equals to 2. So when you come to the fourth term, this is when R is equals to 3. Okay, so the general term, the formula to find general term, let's say this, I'm going to let this particular term be T. So if you're going to find this term, the formula is NR AN minus RBR. Right, so why is it that we want to use this general term? Because supposing if you're asked to expand like 2 minus 3x to the power of 100, right? And if you just need the sixth term, if you just need the sixth term, you're not going to expand, all the terms, all the 100 terms, and then to get the sixth term, right? If you just need the sixth term, then you can use this general term formula, right, to target the term that you want, right? So this is the usefulness of using, getting to know this general term in the formula. So we will do one example on that. Right, supposing if you're given the questions, you're asked to expand in the expansions of bracket 1 minus 2x to the power 8. In ascending powers of x, you're supposed to find the fifth term in part 1, and then part 2 asks to find the coefficient of x cubed. So in this case here, we're not going to expand, we're not going to use binomial theorem to expand all the 9 terms, and from there pick up your fifth term, right? We're not going to do that. So that this is where the general term comes in handy, right? So how do we use it? Let's write down the general term formula first. TR plus 1 equals to NR AN minus RBR. All right, so recall that the fifth term, all right, so we want to find the fifth term. So we are finding T fifth term. So if you do a comparison, your fifth term, and then you compare with the R plus 1, that means you let R plus 1 equals to 5. You are actually substituting your R to be 4. But remember the previous slide we explained, the first term is when R equals to 0, second term is when R equals to 1, third term is when your R equals to 2. So you're finding the fifth term is when your R equals to 4. Okay, right. Right, so we do a comparison first. So we're going to substitute A to be 1, B to be negative 2x, and because there's a negative there, I would advise you to bracket it. And then your N is 8. Okay, so that's to part 1. So we want to find T fifth term. So N is equals to 8, and we're going to substitute R equals to 4. The values of A, it's 1, so it's 1 to the power of N, it's the value of N is 8, so 8 minus 4, bracket negative 2x, close bracket to the power of 4. Right, so you can easily use the calculator to evaluate 8/4. 8/4 is just 8 shift NCR 4, and that gives you 70. So 1 to the power of 4 will be 1, and this one will be negative, bracket negative 2, close bracket to the power of 4, x to the power of 4. This one you apply this rule if you have forgotten. Alright, you simplified it, you will have 70 times bracket negative 2 close bracket to the power of 4, 1120. Okay, so the fifth term in the expansions of 1 minus 2x to the power of 8, it's 1120x to the power of 4. So can you see how powerful this general term is? Right, we're going to do part 2. So to do part 2, let's write down the general term first. TR plus 1 equals to NR AN minus RBR. Alright, so you're asked to find the coefficients of x to the power of 3. So x to the power of 3 means we let R equals to 3. Right, so basically we're actually finding the fourth term. So 8, N is 8. This is your N, this is a value of N, 8. R is 3. This is your A is 1. So 8 minus 3 is 5. This guy here is your value. You can substitute for the letter B. So bracket negative 2x to the power of 3. Alright, so if you use a calculator, 3 is just 8 shift NCR 3. And that gives you 56. 1 to the power of 5 is 1. This one will give you bracket negative 2 to the power of 3. X to the power of 3. Simplify further. Will be 56 times bracket negative 3 close bracket to the power of 56 times bracket negative 2 close bracket to the power of 3. Negative 448, then x to the power of 3. Okay, so therefore the coefficient of x to the power 3. The coefficient, meaning the value in front of your x to the power 3, is negative 448. Okay, the coefficient is the number in front of a variable. Right, let's do some practice. In part 1, to find the 8th term, that will be when r is equal to 7. In part 2, right, you need to be careful. Why is it you need to be careful? In this case here, part 2, all right, you do not let r equals to 10. Why? Right, why? Right, to give you a hint, can you see that what you're getting for b is x squared and not x to the power 1? Right, so that will be the hint. And the answers will be for part 1 and part 2, they're all written on the screen. So try it. Right, so for the first few examples that we have done, we are dealing when a is equals to 1. Okay, we did something like 1 plus b to the power of something, where your a is equals to 1. So the questions that I'm going to ask is what happens when your a is not equals to 1. It can be any other values but not 1. So let's do an example. Say an example. All right, you asked to find the middle term of the expansion 2 plus let's say x over 2 to power of 6. All right, so we're going to we are asked to find the middle term of this expansion. Okay, so there are two things here. What are the two things? The first thing is that what is a middle term? What does middle term means to you? All right, let's look at the expansion. The expansion, it's bracket 2 plus x over 2 to the power of 6. So this is n equals to 6. So when you have n equals to 6, how many terms do you have all in all? Yes, we will, after expansion, you will see that we can have up to 7 terms. All right, so if there are 7 terms altogether, 1, 2, 3, 4, 5, 6, 7. Okay, there are 7 terms up together. Then where is your middle term? Yes, the middle term will be this guy here, right? So this guy will be your middle term. Right, now remember your first term is when your r is equals to 0. Second term is when r equals to 1. Third term, r equals to 2. So if this is your middle term, then that is when your r is equals to 3. So we are actually finding the term when r is equals to 3. So a continuation from the previous slide. So this is what we have. We need to find the specific term when r equals to 3. Let's write down the formula first. So the general term formula is tr plus 1 equals to nr an minus rbr. So we're going to substitute r equals to 3. So that means we're finding the fourth term. N is 6, 3. The values of a will be 2. 6 minus 3, 6 minus 3. values of b will be x over 2 then to the power of 3. Okay, so 3 is 6. Is 6 shift and 3. That gives you 20. Gives you 2 to the power of 6 minus 3 is 3. Okay, this one here, right, we can write it as half times x over 1. Okay, x over 2, you can break it down to be half times x over 2. And if you apply this rule that we keep using it, that we have kept using it, to the power of 3 is 8. It gives you bracket half to the power of 3, x to the power of 3. So if you were to continue further, it's 20 times 8 times bracket 0.5 to the power of 3. That gives you 20x cubed. So the middle term in this binomial expansion, it's 20x cubed. So therefore the middle term so far we have done questions that we know exactly which term we want to locate. For example, the fifth term or the sixth term or the middle term. So what happens if we have a question that we are not told exactly which term? That means we do not know the value of the r, right? And we're supposed to locate that specific term. For example, we may have a question that says that find the term independent of x in the expansion two x minus 1 over x to the power of 8. Right, so if you have a questions like that, you're not told exactly where this independent of x, where this term is. Is it in the middle term? Is it in the fifth term? Is it in the sixth term? Or is it in the seventh term? We do not know, right? So how do you go about finding this term? Well, we will still have to use the formula, the general term formula. All right, the only difference here is that we do not know the value of r. We do not know this guy. Okay. Right, so how do we go about doing it? But we do know that n is 8, so we can substitute 8 into the, let n to be 8, and we do know the values of a, we can substitute it to be bracket 2x. 8 minus r, b, it's negative 1 over x to the power r. Okay, so this is what we know so far. So our job here is to locate the term first. That means locate the position. Where is it? This independent term is at which position? All right, so we need to do some manipulations here. So basically what I need to do here is I need to group all the x term together. So if you look at this, can you see that I have an x term hidden there? And if you look at this guy, I also have an x term hidden there. Right, so what I need to do now is to kind of break all this thing up, and then regroup them. That means I need to decompose this one that I have box it up, and after that do a regrouping. All right, so I'll be using a lot of this rule. Okay, so that will give me bracket 2 to the power of 8 minus r, x to the power of 8 minus r. Right, negative 1 over x, I can write it as negative 1, then times 1 over x to the power r. So again, I can apply this rule here. Right, just make sure you bracket the negative 1. All right, another thing to take note is 1 over x can be written as x to the power negative 1. So that will give me x to the power negative r. All right, so just now we mentioned about regrouping. So what is it that I want to regroup? This guy here, okay, and this guy. I'm going to combine them together. So I would get 8r, 2 to the power 8 minus r. Okay, wait, I don't have enough space there. Okay, just need to write a bit smaller. 8r, 2 to the power 8 minus r. Alright, so that will give me 8 minus r is plus bracket negative r, so that gives you minus r. And of course, your negative 1 to the power r. So let's continue. Alright, I'll get 8x to the power of 8 minus 2r. Alright, okay. So what we're going to do next is that we need to find the position, right? We need to know where this independent of x is. Right, so I already have a general form here, right, where, so the next thing is that I need to understand what is the meaning of the term independent of x. So exactly what am I finding? So the term independent of x means I'm actually finding x to the power of 0. I'm finding the term where it comprises of x to the power of 0. So what I need to do is I'm just going to let x to the power of 8 minus 2r equals to x to the power of 0. So 8 minus 2r is equals to 0. 2r is equals to 8. R equals to 4. So what does r equals to 4 tells you? So r equals to 4 tells us that the term independent of x is the fifth term. It's the fifth term that we are finding. So we have located the position, right? So what we need to do next is to substitute r equals to 4 into the general term that we found earlier, which is this guy here that I boxed it in green. Okay, so hence I'm going to substitute r to be 4 into that. So the term independent of x, it's actually the fifth term, and that is equals to 8. R is 4. Right, 2 to the power of 8 minus 4 is 4. Negative 1 to the power of 4. And you can use a calculator to evaluate 4, which is 8 shift NCR 4 times 2 to the power of 4 times bracket negative 1 close bracket to the power of 4, and you get 1120. So therefore, the term independent of x is the fifth term, which is 1120. Right. Sometimes the questions could be in this way. You're given a binomial expansion and you're asked to find the term in 1 over x to the power 15. So this is something like what we have done earlier. Find the term independent of x. So the term independent of x means we're finding the x to the power of 0 term. Right. So for this, alright, for this what we are finding is we're finding x to the power of negative 15. We're finding the term x to the power negative 15. Right, so how do we go about doing it? Yes, it's the same method as we've done earlier on. We need the specific term formulas so that it's tr plus 1 equals to nr an minus rbr. Right, so like what we have done earlier on, we don't know the value of r. We need to go and locate the position. We need to find where r is. Okay, but looking at what we are given, n is equals to 12, so that I can substitute in r. It's the value that we need to find. A, it's bracket 2x. And the values of b is negative 1 over x squared. Alright, okay. So we're going to decompose this. That will give us bracket 2 to the power of 12 minus r, bracket x to the power of 12 minus r. Alright, then for this guy here, okay, we're going to do the same as what we've done earlier on. Okay, you can split it up into negative 1 times 1 over x squared. 1 over x squared, it's x to the power of negative 2. Right, so we can have negative 1 times x to the power of negative 2 to the power r. Okay, let's continue. Alright, so we're going to group the x terms together. So I'll end up getting 12 minus r plus bracket negative r. So that gives you 12 minus 3r. Alright, so what I'm interested in is in letting this guy equals to x to the power of negative 15. So therefore 12 minus 3r is equals to negative 15. Negative 3r is equals to negative 27. R equals to 9. Okay, so we know that this term x equals to negative 15 is actually the 10th term. Alright, the 10th term. So we are finding the 10th term. So now we know r equals to 9. We can substitute back into here. So that will be 12, 9, 2 to the power of 12, 2 to the power of 12 minus r is 9. So 12 minus 9 is 3 to the power of 3. Okay, bracket negative 1 to the power of 9. And of course, x to the power of negative 15, because this is what we're interested to get, right? X to the power of negative 15. So if we use a calculator to work this out, 12 shift NCR 9 then times 8 times bracket negative 1 cross bracket to the power of 9, you get negative 1760 x to the power of negative 15. So therefore the term in x to the power of negative 15, it's negative 1760.